Hello student, today we are going to discuss the next rearrangement, that is the phrase rearrangement. Right, it is known as phrase rearrangement. So here ester of phenol, let me take one example simultaneously. So this is ester of phenol. Why it is known as ester of phenol? Because this part is of phenol, right? This part from the phenol. If we put here H, then it is the phenol. So here ester of phenol on heating with anhydrous LCl3, anhydrous aluminum chloride, which undergoes rearrangement to give phenolic ketones, and this rearrangement is known as phrase rearrangement. So here your starting material is phenolic ester, which is on reaction with the anhydrous LCl3. So two products is formed mainly. One is orthoketophenol. So the final product is phenolic ketone. So one is orthoketophenol and the second product is paraketophenol. So this is paraketophenol. So one is orthoisomer and the second one is the para-isomer, right? So here the possibility of both the isomer is possible, but as we know that due to sterical repulsion, para-isomer is formed as a major product. So now the problem is that in this reaction ortho and para-isomer both form in the same reaction. That's why these two can be separated by steam distillation. It is separated by steam distillation, as the boiling point of both of these compound is differ. For example, if the boiling point of this para-isomer is 90 degrees Celsius temperature and the orthoisomer is suppose 110 degrees Celsius temperature, so by steam distillation first para-isomer comes out and then orthoisomer comes out, right? So on the basis of physical techniques, or we can say that steam distillation method, we can isolate both the isomer. Clear? Now one important thing is that here aluminum chloride act as a Lewis acid. It is act as a Lewis acid. As we know that the Lewis acid always accept the electron pair. Any Lewis acid always accept the electron pair. Why it is accept the electron pair? Because aluminum having empty p orbitals. So if we write down the electronic configuration of aluminum, we realize that aluminum contain empty p orbital. That's why it can accept the electron from the electron rich species. For example, here oxygen carry 2 lone pair. That's why this lone pair can easily donate into the empty p orbital of aluminum. That's why it is known as Lewis acid. So as per the Lewis acid base concept, Lewis acid always accept the electron pair, while Lewis base always donate the electron pair. Clear? So this is the principle and reaction of phrase rearrangement. Now let me move towards the mechanism part. So in mechanism, two type of the mechanism possible. First one is the intramolecular and the second one is the intermolecular, but here we are only going to discuss the intramolecular rearrangement. Intramolecular means rearrangement within the same molecule. Intramolecular means rearrangement within the same molecule, right? So let me first discuss the how orthoisomer is produced. So our starting material is phenolic ester, right? Okay. Phenolic ester first on react with the aluminum chloride. As we discussed that aluminum chloride acts as a Lewis acid, that's why it attracts the non-bonding electron pair of oxygen. So we got here OCOCH3 as it is, and here LCl3 part attached with the electron rich oxygen. So now here oxygen is the positively charged and whole LCl3 part is the negatively charged, because here LCl3 accept the electron pair from the oxygen, that's why it's negative charge. Here oxygen donate the electron pair, that's why it's a positively charged, right? Okay, I am just showing this double bond in the benzene ring. Okay, now rearrangement take place in such a way that this bond transfer to here, oxygen keto group bond is transferred to here, and this bond transferred to ortho position, right? So this is the intramolecular rearrangement, means COCH3 part transfer from oxygen to benzene ring carbon. So here doubly bonded O, which is attached with the LCl3, and it already a positively charged species. COCH3 part transfer from oxygen to this carbon. So here COCH3, this carbon already contain one hydrogen, so one hydrogen as it is, two double bond as it is, right? Now as we know that any aromatic compound never disturb their aromaticity, so the aromaticity of the molecule is retained or regained by this hydrogen bond transfer to here, oxygen carry its bonding pair of electron, and LCl3 remove from the molecule with the bonding pair of electron, right? So this hydrogen leave as a H plus, this carbon hydrogen electron transfer to here to form the new bond and to re-establish the aromaticity. This bond transfer to oxygen, right? And this LCl3 remove as a LCl3, means we got the Lewis acid again. So now this hydrogen transfer to this oxygen, this hydrogen transfer to this oxygen. So the final product is here OH and here COCH3. This hydrogen here form new bond, this bond transfer to oxygen, and this hydrogen transfer to oxygen. So phenolic group वापस मिल रहा है, and this is the orthoisomer, right? Okay, so this is the how orthoisomer is formed. In the same manner para-isomer is also possible. Now there is a minor change, this bond transfer to here. Now instead of this bond here, this bond transfer to here, and this bond transfer to para position. So now we got this type of intermediate, this bond as it is, ये वाला बॉन्ड यहाँ पे ट्रांसफर हो रहा है, मीन्स यहाँ पे पैरा पोजिशन नेगेटिवली चार्ज है, यहाँ पे क्या ट्रांसफर होगा इस COCH3 ग्रुप, बिकॉज ए बॉन्ड तो यहाँ पे आ गया, दैट मीन्स COCH3 इज नाउ पॉजिटिवली चार्ज विच इज ट्रांसफर टू पैरा पोजिशन, बिकॉज पैरा पोजिशन पे अब नेगेटिव चार्ज है, मीन्स यहाँ पे आ गया COCH3 ग्रुप, यहाँ पे H, here doubly bonded O which is attached with the LCl3, right? So same concept again, the ring occupies aromaticity, so this bond transfer to here, this bond transfer to here, and this oxygen carry bond pair electron, and this LCl3 remove from the molecule, and this hydrogen transfer to oxygen. Clear? So this hydrogen helped to re-establish the aromaticity. Oxygen carry negative charge, which is attached with this positively charged hydrogen. Right, so here COCH3 group is there, and here is the OH. So this is the para isomer. Clear? So this is the intramolecular rearrangement to form ortho and para ketonic phenol. Clear? So out of this two isomer, para is always major, and this one is always minor. This one is minor due to sterically repulsion between these two group, that is the OH and COCH3 group. Clear? Okay. Now we are moving towards the application part. Let me take some simple example. For example, phenolic ketone of naphthalene on react with the anhydrous aluminum chloride. Anhydrous aluminum chloride is important part, because if moisture react with the AlCl3, if this is not anhydrous and some moisture content is there, then AlCl3 react with the water to gives aluminum hydroxide, which cannot be used as a Lewis acid here, right? This one is the base. Clear? So anhydrous aluminum chloride is the important part. So here two product is formed, one is ortho, one is para. Here OCOCH3 group is converted to OH, one COCH3 group ortho position, and the second COCH3 group at the para position. Right? This is ortho isomer, this is para isomer, and this one act as a major product. Let me take one more example. Suppose at both the meta position two methyl group is there. Suppose at both the meta position methyl group is there, then due to presence of this two bulky group nearer to para position, only ortho product form as a major product, or we can say that the only ortho product is formed here. Here H and here COCH3, remaining two methyl group as it is. So here only ortho product form. Clear? Okay. Somehow, if the para position is already blocked, then the reaction goes at the ortho position. Suppose here is the nitro group or any other group. Then the phase rearrangement of this molecule using aluminum chloride, it gives only ortho isomer. Clear? So it gives only ortho isomer. Okay, let me take one last example. Suppose here is COCH3 group, and the para position is also having the OCOCH3 group. Then by reaction with the aluminum chloride, both the OCOCH3 group is converted to OH. So this is the prime condition. Both the OCOCH3 group converted to OH, and nearer to any one OH group, that is a keto group, right? So this is the only product, right? So this we can say that this is 100% product, or we can say that the stereo specific reaction. What is mean by stereo specific reaction? So we can say that only a single product is formed. So we can say that there is a specificity in the reaction. So we can say that this is the stereo specific reaction. In case of the ortho and para isomer, there are selection. It may be ortho or para, right? Suppose 75% is para isomer and 25% is ortho isomer. So we can say that this reaction is stereo selective reaction. For example, A react with the, it gives B plus C. Suppose B is 80% and C is 20%, so we can say that this is the stereo selective reaction, right? So here you have selection, right? You have selection either B or C, so we can say that it is a stereo selective reaction. But if any product is 100% form, then we can say that it is a stereo specific reaction. Clear? So that's it in the Fry's rearrangement. Thank you.